Hey guys, welcome back to the worst YouTube channel on earth. Today we're going to be moving on to our third concept on transformations, which is rotations. So rotations are basically a turn around a point called a center of rotation. So on this diagram right here, this is the center of rotation. So each of these pre-images is being rotated whenever I turn this paper. It's being turned around this one point. So that is the most basic way to explain it. Let's go a bit more in depth now. Here we have a pretty simple diagram. We have the center of rotation, which is point P, and we have a pre-image point. So the first rule about rotations is that when you rotate the point, then the distance from the pre-image point, let's just call that A, the distance from the pre-image point to the center of rotation has to be the same distance from the center of rotation to the final image point. So let's say segment AP is 2 inches, then the segment from P to the image point would have to be 2 inches as well. So a more simplified way of putting it is that the image point will be somewhere along this arc. It will be somewhere along this arc, because every one of these points on the circle is the same distance from P as A is. So one of these points is going to be the final image, depending on the angle of rotation. And we're going to get to that next. So let's say that this was the final image. The angle of rotation is the angle between the pre-image and the final image. The vertex of the angle is the center of rotation. Generally, when we talk about rotations, we're talking about a counterclockwise. So let's say over here, counterclockwise would be this way, because of the way the quadrants are numbered on a coordinate plane. That'd be 1, that'd be 2, that'd be 3, that'd be 4. So we're going in the increasing order of the quadrants. So over here, we would measure this angle in the counterclockwise direction, unless specifically stated. Unless it says a clockwise rotation, we're not going to go this way. We're going to go this way around. So this angle measure right here, this angle measure is the angle of rotation. So let's do an actual problem now. So it asks us to rotate this point 60 degrees. Now remember, counterclockwise. So to do this, you're going to need to use a protractor, because you need to measure out the angle. So the first step to doing this is just drawing the segment between the pre-image and the center. Then, as I did up there, you have to find the distance from the center to the pre-image point. And then with the pin of the compass on the center of rotation, you're going to make a counterclockwise arc. So counterclockwise, for me, is going to be going this way around. So this is a counterclockwise arc, because as you know, every point on this arc is going to be the same distance away from P as the pre-image point is from P. So now we have to put the center of the protractor on P, line it up with that segment, and find 60 degrees. So 60 degrees is right over here. You can just draw on the line, and where it intersects the arc is the final image point. So I'll explain it one more time. So this distance from P, we'll call this A, this is the image. This distance is the same distance as this, because this arc is made with the same radius. And this has a measure of 60 degrees because we measured it with the protractor. So basically what you'd just have to do is pin on the center, counterclockwise arc, measure out the angle with the center of the protractor on the center of rotation, and then where the arc and the line intersect is your final image point. So rotations are sometimes difficult. The concept is easy in and of itself, but if you have multiple points, then your arcs can get mixed up and it can get pretty confusing. So you just have to keep track of that. Analytical rotations are also pretty easy in theory, but when you start doing it, it gets a bit more complicated because you usually have a large number of points. So generally when you do rotations on a coordinate plane, you're going to see one of these three rotations, because these are the easiest and they already have special formulas that will tell you what point you should move your pre-image point to. Any other angle of rotation is going to be pretty difficult to find. So the first one is a 90-degree rotation. So if you have a point xy and you want to rotate it 90 degrees counterclockwise, then it would change from xy to negative yx. So the y-axis would be negative and it would move to the x, the x would move to the y. So let's say right here, I'll use a different color. Let's say we have 2, 3. 2, 3, and we want to rotate it 90 degrees. So 2, 3, the negative yx would make it negative 3, 2. So we went to negative 3, 2. This is 90 degrees. So this is a 90-degree rotation counterclockwise. Now 180 degrees. If you have xy, then it's going to turn into negative x, negative y. Okay, I messed up and the camera did not record properly. I wrote down some stuff and I'll go over that now. So we were just talking about what would happen if you were to rotate it 180 degrees. So when you want to rotate a point 180 degrees, it changes from xy to negative x, negative y. So let's say we have the point 2, 3 over here. To rotate it 180 degrees, like so, then we would change it into negative 2, negative 3. So I plotted that point right here. Let's label these just so that you can be sure. So this is a 180-degree rotation counterclockwise. Now if we want to do a 270-degree counterclockwise rotation, we're going to do it around, we're going to change xy to y negative x. So the y comes first, and then x is negative, and it becomes the y coordinate. So if we have 2, 3, then it would change into 3, negative 2. And you can see I plotted 3, negative 2 right here. So this would be a 270-degree rotation. And I forgot to mention this earlier, but the center of rotation on a coordinate plane is generally assumed to be the origin right here. Because if you don't assume it to be the origin, then none of these formulas work. All of these formulas only apply if the center of rotation is an origin. So generally you're going to see, well, almost always, or I can dare to say always, the center of rotation is going to be the origin when you see a coordinate plane. So I drew some of these extra lines and I'll explain what they mean. So basically, if you have 90 degrees counterclockwise rotation, so this right here, that's essentially the same as saying 270 degrees clockwise. Clockwise would be in this direction, so 270 degrees clockwise would end up at the same point as 90 degrees counterclockwise. 180 degrees clockwise and counterclockwise is the same because it's a semicircle either way. And 270 degrees counterclockwise is the same as 90 degrees clockwise. So let's move on to some practice problems now. So let's start with this. Rotate 120 degrees about point P. So we did it before with just one point. So now that we have several points, it's going to be a little more difficult, but not too hard. So let's just first find all the segments. And then we're going to use our compass to make arcs with the pin on the center of rotation. Remember not to put it on the vertices of the figure that you're using, or the point or the end of the segment. That's a common mistake, and then it ends up with you getting the wrong answer. So remember, your pin of your compass goes on the center of rotation, not anything else. You find the distance from this to this point. I'll start with this vertex of the triangle first. Counterclockwise arc. I'll just repeat the process for each of the other ones. So counterclockwise arc. And now let's use our protractor to measure out 120 degrees for each. So remember, you can keep track of which arc belongs to which line. So I'm going to start with this vertex once again. So this line right here is the one that we're looking for. So I'm going to line up the protractor with that line. Okay, and 120 degrees is, oh, protractor's flipped over. Yeah, if your protractor is flipped over, it actually will not work the same as if it was not flipped over. So make sure your protractor is facing the right way. 120 degrees is right here. So then, which arc are we looking for? Okay, this arc right here. So that is your first reflection, your first rotation point, sorry. And now we'll just repeat the process for the other 2 points. And now we have our final answer, which is this triangle, which has been rotated 120 degrees counterclockwise. So there we go. Let's move on to this one. Rotate a trapezoid 200 degrees around point P. So we'll just do the same thing as before. You already know the drill. I'll do 1 point with you, and then I'll get back to you when I'm done. So let's choose the closest vertex. Oh, this actually brings up an interesting point. What if the rotation is more than your protractor? This protractor only goes up to 180 degrees, and it asks us for a 200 degree rotation. So let's find out how we do that. Let's draw the segment first. We'll make the counterclockwise arc. Since it's 200, it should be a pretty big arc. So I'll make it go pretty far around, about that much. So you can't put it right here because the farthest you could measure is 180, and that's not enough. So instead, you should turn it around and put it on this side. So right here, this is 180. So you want to add whatever you're missing on this side. So 200 minus 180 is 20. So you want to find 20 degrees. So 20 degrees is right here. So there you have it. So this angle right here is 200 degrees. Okay, sorry, camera troubles once again. But as I was saying, if the angle of rotation is greater than your protractor can measure, you just turn it over and you add what's missing. So you would take the angle of rotation minus 180 and measure that amount on this side. So right here, the point is right there. I've already marked it in, and I'll do the rest and get back to you. Okay, so I've got all the points, and all we need to do now is connect them all. So there's a bunch of arcs, so just remember to keep track of which one is which, and you should be fine. So now we have our rotated trapezoid 200 degrees around. So now let's go on to some analytical problems. So the first question asks us to rotate 90 degrees, and we know that that means about the center, or about the origin, and counterclockwise. So we also know that if we want to rotate 90 degrees, then xy turns to negative yx. So I'll do this all in my head. Again, if you have trouble doing it in your head, you can write it down. So the first one is not negative 2. The first one is 2, 2. So it would be negative 2, 2. Then it's negative, I keep saying negative today. The next one is 4, 0. So it would be 0, 4. And then 4, 2. So it would be negative 2, 4. So now let's just connect the dots. And now we have a rotated 90 degree triangle. So the next question is to rotate this segment 180 degrees around. So let's do that. So 180 degrees is probably the easiest one because you don't have to switch anything around. You just turn both of them negative. So 1, 2 would be negative 1, negative 2. And 3, 3 would be negative 3, negative 3. So that's pretty easy. And we just need to connect the dots. And then we have our 180 degree. So 1, 2, 1, negative 2, 3, 3, negative 3, negative 3. So the next question asks us to rotate it 90 degrees clockwise. And if you remember from before, 90 degrees clockwise is the same as 270 degrees counterclockwise. And we know that the rule is for 270 degrees counterclockwise, xy changes into y negative x. So we'll just do that now. 0, 3. 0, 3, that would change into 3, 0. So right there. 4, 1 would change into 1, negative 4. 5, 5 would change into 5, negative 5. So where's 5? 5, negative 5. So there we go. Connect all the dots. And there is your 90 degree clockwise rotation, also known as a 270 degree counterclockwise rotation. So now on to the last problem. This is actually the hardest one out of all of them, and I'll leave you guys to do it by yourselves. Good luck.